All right, here we go. Here is today's homework from the book. As always, remember you can pause the video at any point in the return. All right, today we're moving on to another new thing. This chapter is full of new things. This is called graphing linear inequalities. Last chapter, we graphed plenty of linear equations. Now we're going to be graphing linear inequalities. So this might be a new thing for you. 3 objectives. The last one, they're using a graphing calculator. We usually don't get to that on the first day, but I'll get to it by the second day. All right, so think about this. So solutions to equalities. Here's a linear equation. How do we find solutions to equations? Well, for instance, is 1, 3 a solution to that equation? Well, look at that point there, 1, 3. 1, 3 is always of the form, it's an ordered pair, so it's always of the form x comma y. So if we toss those two values, x equals 1 and y equals 3, into that given equation, so in other words, replace the letter x with 1, replace the letter y with 3, and see if the left side equals the right side, and 3 is definitely equal to 1 plus 2. So we can confirm that 1, 3 is a solution to that equation. So check. So linear equations, remember, are equations of the form where you have 2 variables, and typically it's y and x, and they make lines, right? If we graph all the solutions, remember, they make lines. And so, for instance, this is the line it makes. And if you can remember way back when we did this last chapter, to graph this line without finding a bunch of solutions, we graph the y-intercept, which is 2, the slope, which is the number attached to x, that number is 1, so up 1 over 1, put a couple dots, connect the dots, and there's that red line right there. Remember, the solution will include the one that we just said is a solution. So the solution is the red, or the solution to the linear equation is the red line. That is all the solutions. Remember, there's an infinite number of solutions to this equation, and 1, 3 is one of those. So I'm circling it. That's not the actual point. I'm circling where 1, 3 is. So what would happen if we did solutions to inequalities instead of equations? Well, it's very different. So there is a linear inequality statement. I have 2 letters, y and x, and I don't have an equal sign. I have a less than symbol. Well, we can do the same thing as the previous one. We can throw in some values and see if there's solutions. So is 1 comma 4 a solution to that linear inequality? All right, x is 1, y is 4. Toss those 2 values into our equation. Let's see, is 4 smaller than 3? I'm just adding 1 plus 2 there, and the answer is no. So 1 comma 4 is not a solution to that particular inequality statement. So where am I going with this? Well, I mean, we can do this for a long time. Is 1, 2 a solution to this linear inequality? Let's see. X is 1, y is 2. Throw those 2 values in, and yes, 2 is smaller than 3. So 1, 2 is a solution. Here's another different type of equation. Yes, we'll have a lot of fractions today as well, too. Is -5 comma -4 a solution to the inequality? Let's throw in x, let's throw in y. So let's see, x is -5. I'm going to do a little bit of work for this one. Let's see, what's -5 times 1/5? Well, remember, when we have fractions and whole numbers, we multiply straight across, or we cross reduce. 5 goes into 5 once. So everything in red turns into a 1. So we get -1 times 1, which is -1, and -1 plus 2 is 1, and -4 is less than 1. So yes, that is a solution as well, too. So the first thing they'll give you in homework is they'll give you a linear inequation, and they will give you potential solutions, and you're just confirming whether or not they actually make the inequality true or false. So we take here, here's 2. If you know what you're doing, pause the video, get to an answer. The answer will be yes or no. If not, stay on. I'll show you how to do it. So let's see, linear inequality. The first one there on the left is 3, 6 a solution. So let's see, I need to let x be 3 and y be 6. I'm going to multiply 2/3 times 3. So the 3's would cancel, and we'd be left with 2 plus 4, which is 6. And 6 is not less than 6, but it is equal to 6. So yes, that is a solution. How about the second one there on the right? Always be careful when you have negatives. Let's see, x is -1 and y is -1. So toss those 2 values in. Let's see, a negative times a negative is a positive. So -3 times -1 is 3, and 3 minus 2 is 1. And is -1 bigger than 1? No, so that is not a solution. All right, so that's our first goal is, can we find out solutions to linear inequalities? They will give you a potential solution. You just confirm or deny it. All right, the second one, which we'll spend the most time on, graphing linear inequalities. Ends up being a little bit easier than you think, but it does require a couple extra steps than linear equations. So if I gave you a linear equation and asked you to graph that equation right there, remember, we got a y-intercept. As long as it says y equals, we have a y-intercept and a slope. So for instance, if we tossed 1 in for x, let's see, if we let x be 1, 1 plus 1 is 2, so y would be equal to 2. I'm just letting x be the value 1. That is one of many, 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 many answers. Could we do the same thing for inequality? We sure could. We could throw in 1. 1 plus 1 is 2. And let's see, 2 is in fact, no, 2 is not smaller than that. So we could take every one of those potentials right there and figure out if they were true or false. Some of those will be true and some of those would be false. The issue that I want to make of this slide is that when we throw in 1, there's lots of answers to inequalities where there's only one answer to equations. When I throw 1 into that equation, we only get 2. But when I throw in 1 for the inequality, 1 plus 1 is 2, so I need a number that's bigger than that. So let's see, 0 is smaller than 2, so that would be the value that would make it true. But there's other values like -1 or -4. They would all make throwing in x would make that equation true. We have a slight problem. For equations, right, we only get one answer, 2, 3, but with inequalities, we get an infinite number of answers. If we graph 2, 3, right, there's 2, 3 right there. Here's another solution, throw in 3 and we get 4. Here's another solution, 4, 5. If we graph those points on the number line or on the coordinate plane and then eventually connect the dots, we eventually wind up with our line. Now we know an easier way of graphing the y-intercept and the slope, but we could do it the traditional way of just plugging in points. The problem with inequalities is that there's just not one answer to 2. There's lots of answers for 2. If I throw in 2, well, 2 plus 1 is 3. Well, any number that's smaller than 3 would make 2 correct, right? Any number smaller than 3. So the question is, if the x value is 2, where are the values that are smaller than 3? Well, 2, 3 is not one of them, right? That doesn't work. But any number that's smaller than 3 would work. And where are the numbers that are smaller than 3, right? The numbers that are smaller than 3 would be straight down from 2, right? Straight down. In fact, every time that I do a number that's smaller than 2, smaller than 3, smaller than 4, smaller than 5, that would make that inequality true. So if you notice what the shape that's appearing right there, it's not a line, but it's a region. And that region in red is what would make that inequality true. So solutions to linear inequalities are regions. They're not a line, they're entire regions. So we represent, when we actually graph this, we represent that region by shading a portion of the graph. And the shading is where all the values would make the inequality true. So today, that's what we're going to do. We're going to graph a linear inequality, and we're going to find the region that makes it true. The but here is this. There's a lot of steps here. So the steps are, let's see, step number 1, get y by itself. Step number 2, you're going to graph the inequality exactly the same way you're going to graph a linear equation. You're going to use the slope and the y-intercept. Step number 3 is you're going to not connect the dots in the normal way. You're either going to put a solid line or you're going to put a dashed line, just like an open and closed circle before. A solid line if there's a line underneath the greater than or equal to symbol, and a dashed line if you're missing that. Lastly, you're going to do something called pick a test point. You're trying to find out which region is true, where the answers lie, and you're going to shade the region that is true. Now, that won't make sense to you right now, but those are the steps. but after we do some examples, it should make sense to you. So watch me do this one. So step number 1, it says get y by itself. Well, y is by itself. Step number 2, we're going to graph that inequality exactly the same way we graph an equation with the y-intercept and the slope. So let's see, the y-intercept is 2 and the slope is 1. So from that red dot, up 1 over 1, up 1 over 1. If we want to go in the other direction, down 1, left 1. So those points represent where the line is. And if this was last chapter, we'd play connect the dots and we would be done. But this is a linear inequality. So now we have this step. If it's less than or equal to or greater than equal to, you're going to draw a solid line through those dots. If it's less than or just greater than, you're going to put a dashed line. So if we look at our equation or inequality there in blue, it's a less than, so we're going to put a dashed line or a dotted line. Now, if we look at that dotted line, there's a region above the dotted line and there's a region below the dotted line. One of those regions is the answer. So how we find out the region is we pick a test point. And if you notice, the easiest test point to pick is 0, 0. 0, 0, if you look on the graph, will be right at the center. That is either going to make the linear equation or linear inequality true or false. If it makes it true, well, then that's the region underneath the dotted line. If it makes it false, well, then it's the other region. The other region is above. The dashed or dotted line splits the graph into two regions, either the true region or the false region. We need to find the true region. So we pick a test point. And by the way, you can pick any point you want. We just would like to pick 0, 0 because it makes the math easy. Watch how it makes the math easy. Well, 0 is x and 0 is y. So oh, and one quick note, if the line goes through 0, 0, you can't pick 0, 0. But this time that dotted line does not go through 0, 0, so I'm going to pick 0, 0. I throw 0, 0 into the inequality. I simplify both sides. 0 plus 2 is 2. And I see if that last statement there on the bottom is true or false. Is 0 smaller than 2? It sure is. So 0, 0 lives in the correct region, and 0, 0 is underneath the line. So that's the area that I shade. Now, what do you mean by shading? I mean that right there. Some people put a squiggly line, but you shade. Some people actually do a complete shading. It's entirely up to you. Now, what would have happened if 0, 0 would have been false? I would have shaded the other side of the dash line. So you always shade the true region. All right, let's do another one. Step number 1, get y by itself. Hey, look, y is by itself. Step number 2, we're going to graph that sucker just the way we graph an equation. So y equals negative 2x. So let's see, the y-intercept, since there isn't a y-intercept, that means the y-intercept is 0. The slope is negative 2 over 1, so down to right 1, down to right 1. If we want to go in the other direction, up to left 1. So put about 4 dots right there. Stop. Decide whether it's I put 5. Decide whether it is a solid or dashed line. Well, let's see. If it's less than or equal to, it's solid. If it's just less than, it's dashed. So we put a dashed line. Now we pick a test point. So let's see. The test point we like to always pick is 0, 0, but this line goes through 0, 0. So here's my recommendation. Don't just pick any old point. And you can pick any old point. Pick a point that causes you the least amount of work and the least amount of problems. I could pick 4, 7 if I wanted to. 4, 7 is to the right of that dashed line. Then I have to throw 4 in for x, 7 in for y, but I could pick an easier point. I could pick 1, 1. And why would I want to pick 1, 1? Because 1 is a small number. It's easy to do math with small numbers. Why do I pick the same number, 1, 1? That way, there's no way I can mix it up and place it in the wrong spot. So pick a nice friendly number. I wouldn't pick ever pick any negative numbers. I would pick a nice friendly number like 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So I'm going to pick 1, 1. Once again, I pick 1, 1 because when I throw it in, the number is small and I can't mix them up. Even if I put the 1 in the wrong place, well, they're both 1s, so it wouldn't make a difference. So I'm going to throw 1 for y, 1 for x, do the math. Negative 2 times 1 is negative 2, and then look to see if that's true or false. Is 1 smaller than negative 2? No. So 1, 1 is on the false side. 1, 1 is to the right of that dotted line, so we're going to shade the other side. Does that make sense? We're just going to be doing a bunch of these today. All right, number 3, if you know what you're doing, pause, do this one. All right, so let's see. Okay. Y is by itself. Eventually, y will not be by itself. Graph this exactly the same way you do an equation. So let's see, the y-intercept is -1, and the slope is 3. So up 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. If we want to go in the other direction, down 3, left 1. Once you have 4 or 5 dots, then decide whether it's solid or dashed. Hey, look, it's got a line underneath the greater than symbol, so it's going to be a solid line. Now pick a test point. It's either going to be shaded to the left or shaded to the right. Well, let's see. 0, 0 doesn't go through the line, so we could pick 0, 0. You can pick any number you want. I would always pick 0, 0 if you can. If not, pick 1, 1 or 2, 2. So I'm going to throw 0, 0 back into the inequality. That 0, 0 is on the left side of that solid line. So if it's true, I'm going to shade left. If it's false, I'm going to shade to the right side. Remember, the point cannot be on the line. So throw in 0, 0. 3 times 0 is 0. So you get 0 is greater than or equal to -1, and that is a true statement. So if 0, 0 is on the left side of that line, and it's true, it is true, I'm going to shade the left side. Some people do shading just the way I just showed you right there, and that would be perfectly fine. All right, if you know what you're doing, do this one all by yourself. Okay, so let's see. Is y by itself? Yes. Graph the line. The y-intercept is 3. I'm going to actually do this one by hand. Y-intercept is 3, so we put a dot on 3. The slope is up 1 over 3. So up 1 over 3, put a dot. Do it one more time, up 1 over 3, 1, 2, 3. Put a dot. If you want to go in the other direction, down 1 over 1, 2, 3. I wouldn't put more than 4 dots. And now decide whether it's solid or dashed. It's strictly greater than, so it's going to be a dashed line. Dash, 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 dash. And it is a line, so put arrowheads. Now pick a test point. Notice we will always want to pick 0, 0 if possible. So 0, 0 is right here, and we can pick 0, 0. Now do the math. So the inequality says that y is greater than 1/3 x plus 3. So I'm going to replace x and y since my test point is 0, 0. I'm going to replace x and y with zeros. So my inequality would now say y is greater than 1/3 times 0. We like that. That would be 0. Plus 3. If 0 times 1/3 is 0, then we would get 0 is greater than 3. Is that true or false? 0 is not greater than 3. So we're not going to shade the blue side. We're not going to shade the blue side. Let me erase that blue now. We're going to shade the other side. So we're going to shade this side. So how would I draw that? I'm just going to draw some shading. So some people go like that. They just draw some wiggles over here. And that is the side that's shaded. Make sense? Okay. All right. One more? Sure, one more. All right. Let's see. The y-intercept is -2. So put a dot on -2. Oops. I'm sorry. It keeps switching on me. -2. The slope is -2/5. So down 2. Over 1, 2, 3, 4, 5. Do I have room to put another dot? Down 2, over 1, 2, 3, 4, 5. Just enough room. Go up 2, over 1, 2, 3, 4, 5. Go up 2, over 1, 2, 3, 4, 5. There we go. Solid or dash? Let's see. Oh, it's strictly less than, I mean, it's less than or equal to, so it is a solid line right through the dots. Pick a test point. I'm going to pick, well, you know me, I'm always going to pick 0, 0 when I can. So 0, 0, I'm going to pick that test point, throw 0, 0 into the inequality. I'm just going to go and throw the numbers in. 0 for y, 0 for x, negative 2/5 times 0 is 0, minus 2. When we simplify that, it would say 0 is smaller than or equal to negative 2. True or false? That's false. 0 isn't smaller than 2. So I'm going to shade the true side, and the true side is on the side. Any point in that area right there would make the inequality true. All right. One more, I think. Yeah, here we go. And then we get some special ones. All right. The y-intercept is 1. That's a horrible dot. Slope is negative 1/3, so down 1 over 3. 1, 2, 3, almost went 2. Down 1 over 1, 2, 3. I think I can get another point. Down over 1, 2, 3. We go in the other direction, up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And that's enough dots for me. Solid or dashed line, it looks to be solid. So I'm going to draw a solid. You know what? I forgot to put arrows on my last time I did that. Oh, there's your arrows. Don't forget your arrows like I did. Can we pick 0, 0? We sure can. The only time you can't pick 0, 0 if the line goes through 0, 0. So I can pick 0, 0. If I pick 0, 0, throw in 0 for x and y. So we would get 0 is greater than or equal to 1, negative 1/3 times 0 is 0 plus 1. Is 0 bigger or equal to 1? No way, no how. So 0 is on the false side. We want to shade the true side. So this is the true side right here. And that's all you got to do. All right, going through these pretty quickly. There are some special case ones. Here's a special case one. Let's see, y is greater than 3. That's a horizontal line at the value 3. You should remember that from last test. So if y is greater than 3, then that's a horizontal line that goes to the y value 3. Pick a test point. Let's see, the test point is 0, 0. So there is, oops, that's not what I want. I don't want a line. I want some text. Is 0 smaller than 3? Is 0, I'm sorry, smaller. I meant bigger. Is 0 bigger than 3? Nope. So let's see, this point right here where 0 is on the false side. So we want to shade this side. Do it in all sorts of colors here. Hopefully you're seeing that this is a pretty simple task. Tomorrow's the more challenging task. One more of these. Let's see. Y is less than or equal to negative 2. I gotta apologize. I gotta go back one. I gave you the right answer, but that should have been a dashed line, not a solid line. So it is a line, but it would have been a dash. Let me do that in red. It would have been a dashed line. So dash, 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 and arrowheads. And we found out that 0, 0 would make this false. So we're going to shade that side. Okay, fixed my mistake. All right. And the only reason I said that because I looked at this one and realized I made a mistake. This one is a solid line at negative 2. Remember, x equals is a vertical line, y equals is a horizontal line. So that's a horizontal line at negative 2. I'm going to pick 0, 0 to toss in. Is 0 smaller than or equal to negative 2? We're getting a lot of false answers here, and that's false. So I'm not going to shade the side. 0, 0 is right here, so I'm not going to shade that side. I'm going to shade this side right there. Okay, and that was box number 8. And finally, I got a vertical line here. And it's going to be solid because it says less than or equal to. So let's see, at the 1 value, it's a vertical line that goes through 1. I'm going to pick 0, 0 once again. So is 0 smaller or equal to 1? Finally, one that's true. So 0 is a true statement. 0 is right here. So we are going to shade the side that has the 0 because it's true. If it was false, we shade the other side. There you go. And that was box number 9. Oh, they continue. I thought that was the last one. Box number 10 must be the last one. It's another vertical line at negative 3. So we can do that one. It's dashed, so I can't use that. I got to use a dashed line. So a dashed line at -3. So dash, 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 arrowheads. Oops. Arrowheads at the end. Pick a test point. We're picking 0, 0. So is 0 bigger than -3? Yes, sir. 0 is bigger than -3. So I'm going to shade the side that has 0 on it. There you go. Done. Easy. Hopefully you're seeing that they're easy. Last thing, a couple remember things. Remember, in order to graph, it needs to be in the form of y is equal to mx plus b. So if it's not, right, that one is, you're good to go. The but here is, well, what happens if it's not? Then you just do a little bit of algebra and you make sure it does. So all I have to do, that one there on the right there, is add 5 to both sides. And well, now it is in the form of y equals mx plus b. The more complicated ones, so be careful on these, kind of look like this. So let's see. To get y by itself, I would have to add 6 first. So I would get that, and then I would have to divide everything by -2, and this is why there's a b there. You got to be careful, because remember, if you divide everything by -2, you're dividing by a negative, you'd have to flip the inequality. 2 divided by -2 is -1, and 6 divided by -2 is -3. But I would need to flip that less than symbol and make it a greater than symbol. So keep that, and there's a couple tonight for homework where you have to do that. I said I was going to hold the graphing calculator until the next class, and I will do that for Friday's class. So we'll do the graphing calculator on Friday. So that is it for today. Here, once again, here is your homework. Good luck. Make sure you're doing your homework, turn it in, and you will pass this quarter.